Good evening, students. Today we are going to discuss grade 11 thermodynamics, enthalpy of formation and combustion, JEE NEET questions. First, observe the question number 1. The heat of combustion for carbon, hydrogen and methane. They have given these values in kilojoules and they are asking what is the heat of formation of methane. So you can write the symbol delta FH. So standard enthalpy of formation. Before we start, let us write the required equation. What is the required equation? Heat of formation of methane. So the formula CH4 you write on the product side. Now if you observe how many carbons are there? 1. So let us write like this. So carbon, and always you know the standard form of hydrogen, that is H2. Because you are having 4, let us write it as 2. Now this is your required equation. So formation for any molecule we can write like this, and now delta FH. So on the standard condition you can calculate. So they are asking this. Now what is the first one? Heat of combustion. What is meant by combustion? Burning anything in presence of oxygen. If you heat this, the product will be CO2, and they have mentioned combustion we can write as CH, that is nothing but minus 349 kilojoules. Next, H2 combustion. So we all know that for 1 mole of any product we have to consider, therefore you have to take H2 only. Here we have taken CO2. Now H2 is balanced for oxygen, we can write it as half O2. So here delta combustion, what will be the value? Minus 241.8 kilojoules, exothermic reaction. Now third one is heat of combustion of methane. CH4 plus O2, the product will be CO2 plus H2O. So that is nothing but minus 906.7 kilojoules. Hope you have understood this. We have written equation 1, equation 2 and equation 3. So these 3 equations we need to convert into this form. So let us check it. First one, carbon is as such, so circle that. Next, 2 H2 we have, but here you are having only 1 H2, therefore you need to multiply the whole equation, that is equation 2 should be multiplied with the 2. Up to this you need to multiply. Now on the product side you are having CH4, but here it is on the reactant side, therefore equation 3 should be reversed. So reverse equation 3. Now the whole thing let us write again. First one, C plus O2 gives CO2, delta, that is combustion, is nothing but minus 349 kilojoules. Now second equation we have to multiply, hence 2H2 plus 2 into half O2 gives us 2H2O. Now delta will become, we have to multiply into 241.8 into 2. Next, third one you have reversed, therefore CO2 plus H2O gives CH4 plus O2. Now important thing here is when you are taking this equation 3, it was minus 906. If you reverse it, it will be plus 906.7 kilojoules. Now this is your new reactions. Next, what is the required equation? This is the required equation. So C you have to underline or circle, then 2H2 you circle this. On the product side you have to take methane, circle. Now the other things gets cancelled out. You can just observe this. So CO2 gets cancelled out. So here we didn't balance this. Let us balance CH4 plus O2 gives CO2 plus H2. So we have 2H2O here. Fine. Now oxygens you just consider how many oxygens are there? 2 and 4. So here 2 plus 2. So hence it will become 2O2. So here it was 2O2. I didn't observe that, so you can balance that. This is 2H2O. Hope you have understood this. We need to balance the combustion equation. Now this gets cancelled out, CO2, and then 2O2 is there. Here 2O2 gets cancelled out, 2H2O and 2H2O. Therefore C plus 2H2 gives a CH4. We got the required equation. Now we need to take care of the calculation part. Hope you have understood this. First you take minus 349. Now this into 2, how much you will get? 8 to 16, 2 ones 2, 3, 4 twos 8 and 2 twos 4. So we got 483.6. So both are in minus and this is plus, hence first add this. We get 9, 3, 12. So we have 5, right? So 13. And this is minus 832.6 kilojoules. So we have plus 906. So let us find out the answer here. 906.7 kilojoule minus 832.6. We have 6, 2 is 4. And here we have 10. Hence we can get it as plus 74.1 kilojoule. So just observe that. Answer is D. Hope you have understood this very simple method. First you need to write the required equation, then take the given equations and convert the given equations into your required form. And after that cancel the delta H values accordingly. So finally we got 74.1. Hope you have understood this. Copy the solution and let's move to question number 2. Next, question number 2. From this thermochemical reaction, that is graphite plus half O2 gives CO, they have given delta H for this. Then CO plus half O2 gives CO2, delta H is given. They are asking find the delta H for graphite plus O2 gives CO2. Now the given two equations are there, you need to convert into this. Just observe here itself. We can see that in the equation 1 you have as it is. Next, CO2 is also on the product side. Fine. So therefore what we can do is, straight away you can add these two reactions. So let us add C graphite plus half O2 gives CO. Delta H is minus 110.5 kilojoules. Second one, CO plus half O2 gives CO2, delta H is minus 283.2. Now we need to add these two. So first circle what is required. C graphite plus O2. This is O2. Half O2 plus half O2 gives O2 and CO2. Next, cancel CO on LHS and RHS. We can cancel this. So we got C graphite plus O2 gives CO2. Now you need to add this. Let us see, 7, so 3, 9 and minus 393.7 kilojoules. Hope you have understood this. So where is the option? Option A. So very simple, given equations you need to convert into the required form of the equation, and then here we have simple addition. There is no reversal or multiplication, so simple addition will give you minus 393.7. Copy the solution. Let's move to question number 3. Next, question number 3. They have given if heat of formation of ethane and benzene 230 kilojoules as well as 85 kilojoules. They are asking delta H for trimerization of ethane. So what is meant by trimer? So we have to take 3 moles of C2H2. See what will be the product. If you write like this, we have discussed also. Three molecules if you take CH triple bond CH. Now if you have the trimer of this, so what happens? The pi bond will move to the adjacent position and you are going to get benzene here. So CH, CH like this. Hope you are able to understand this reaction. So conversion of 3 moles of ethane into benzene. So here they are asking what is the value of delta H. Hope you have understood this. We have taken 3 moles of ethyne and then so trimerization. So we have the conversion of pi bond to this. Hence you will get the benzene. Now this is your required equation. So what is the required equation? 3C2H2 gives C6H6. Now first arrange this given information, heat of formation of C2H2. So equation 1 is nothing but formation of C2H2 delta FH. So how much is that? 230 kilojoules. Now how many carbons are there? You know the formation. So if C2H2 they have mentioned 2 carbons, we can take plus H2 can be always written in this form. Now we can get 2C plus H2 gives C2H2. This is equation 1. Now what is the second equation? Heat of formation of benzene, nothing but C6H6. So delta F is nothing but 85 kilojoules. So how many carbons are there? 6 carbons. Therefore write 6C plus H2 should be written in this form. And 6 we have, therefore mention the coefficient as 3. So this will be your equation 2. Hope you have understood this. Given information I have written in the form of equation. Now to get 3C2H2 and here you are having only C2H2, that too on the product side, what we need to do, we have to reverse this equation. Second one is multiply with 3. Multiply with 3. So very simple. Why you have to reverse this? Because it's in the reactant side, but here it is in the product side. Reverse this. Now 3 moles are there, hence multiply with 3. What you get on reversal and multiplying, we get 3C2H2 gives us 6C plus 3H2 and delta H. Now it was earlier plus. On reversing it will become minus and then multiply with 3. Hope you have understood this. This will be your equation 1 converted. Next, second one. See, balance this, how to make it out. Product side is same, hence we can write like this. 6C plus 3H2 gives C6H6. As it is plus 85 kilojoules. Now how to solve this? Circle what is required. 3C2H2 I have circled, benzene I have circled, remaining thing gets cancelled out, 6C as well as 3H2. Now we got 3C2H2 gives C6H6. Hope you have understood this. Very simple. These are the given equations and we have converted in the form of required equation. First one, because it is on the product side, it is reactant, you have to reverse this, and 3 moles are there, 1 mole, so multiply. So we have done this. But second one is as such. Now what we need to do, we have to solve the enthalpy. First minus 203 into 3, what you get? 9. So 0 and 6. So we have 609 minus 609 and this is 85. So let us take plus 85. So 4. So this will be 2 and 5. So we have minus 524. So 3, 2, 609, 85, 4. Now I have solved this. They have given 230. So 230 into 3, nothing but minus 690, and here it is 85. So we have minus 605 kilojoules. So answer is B. Hope you have understood this. Copy the solution and let's move to question number 4. Next, question number 4. The given information, heat of combustion of graphite and H2 minus 395 and minus 269 kilojoules. If heat of formation of glucose is minus 1169 kilojoules, they are asking what is the heat of combustion of glucose. First one, what is the required equation? They are asking heat of combustion of glucose, C6H12O6 plus O2 gives CO2 plus H2O delta CH they are asking. First to balance this, to balance the combustion, always you need to follow CHO order. How many carbons? 6. Write 6 CO2 on the product side. Next, C is done. Hydrogen 12. Write 6 H2O. Now observe oxygens. 6 into 2 12 plus 6 totally you have 18 oxygen. Here already 6 there. So remaining 12 we have to write 6 O2. Hope you have understood this. Always balance in the order of CHO. This will be your balanced equation and you need to find out delta CH for this. Now equation 1. So the heat of combustion of graphite. So C, nothing but graphite. Combustion means in presence of oxygen. If you heat, the product is CO2. Here delta CH is nothing but minus 395 kilojoules. This is equation 1. Second one, combustion of H2. H2 plus half O2 gives H2O. So the combustion value minus 269 kilojoules. So this is your equation 2. Now if heat of formation of glucose, equation 3, heat of formation of glucose, formula C6H12O6. Now observe this, how to form glucose. 6 carbons plus hydrogens, we have to write H2 form, 12 means 6H2. And oxygen 6, O2 is the elemental form and we can write it as 3O2. So this is the heat of formation of glucose, delta FH. You know that delta F represents heat of formation here, delta HF. Now value is minus 1169 kilojoules. So hope you have understood. We have written all the 3 equations. How do you convert into the required equation? Observe carefully. Glucose here is on the right hand side. Therefore what we will do, we need to reverse this. Equation 3 we have to reverse because it's on the reactant side. Here it is on the product side. Next, observe here you have 6 O2 that we will see. Now 6 CO2 and 6 H2O. We have only 1 mole of CO2 and H2O. So what we need to do, these equations must be multiplied with the 6. Hope you have understood this. If you multiply that, automatically oxygen will be balanced. First observe the reactants as well as the products, and to convert into 6 CO2, equation 1 should be multiplied with 6. To convert into 6 H2O, equation 2 should be multiplied with 6. Write down this now. So we can take it as 6C plus 6O2 gives 6CO2, and here it is minus 395 into 6. We can calculate it later. Second one, 6H2 plus 1 by 2 into 6 will become 3O2 gives 6H2O minus 269 into 6. Now equation 3 you reverse this. C6H12O6 gives 6C plus 6H2 plus 3O2. Because minus we have, on reversing it will become plus 1169 kilojoules. Next, follow the same method. This is the required equation. So circle glucose, 6O2, circle 6O2. Next, product side 6CO2 you circle and 6H2O. Automatically the other elements gets cancelled out. 6C, 6H2 and 3O2. Hope you have understood this. Now C6H12O6 plus 6O2 gives 6CO2 plus 6H2O. So we got the required equation. Now we need to solve the enthalpy side. So let us see this. So first multiply this. 6 5s 30, 6 9s 54, 57, 6 3s 18, 19, 23. Hope you have understood this. Multiply this. 6 5s 30, 47. So minus 2 3 70 kilojoules. Next, the second one, 6 9s 54, 6 6 36, 41, 6 2s 12, 4 16. So this is minus. First add this, what you get? 4 8 9 minus 3984 kilojoules, and here you have plus 1169. Subtract this 5. Here you have 7 minus 6, 191 is 8, 31 is 2, minus 2815 kilojoule per mole. Observe. Yes, you have option C. So this is your correct answer. Hope you have understood this. First and foremost thing is write the required equation, that is combustion. Hence we need to write down glucose plus O2 gives CO2 plus H2O. Then balance that. What is the order of balancing? Always carbon, hydrogen and oxygen. After balancing that, we have changed the given information into equation form and finally convert that into the required equation. The last step is find out the enthalpy. Hope you have understood this. Copy the solution. Let's move to question number 5. Next, question number 5. When certain amount of ethylene was burnt, 622 kilojoule heat was evolved. They didn't mention the value. If heat of combustion of ethylene is 1411 kilojoules, find the volume here. First we will get the mass, then we can calculate the volume. So what is given here? Heat of combustion of ethylene, C2H4 plus O2 gives CO2 plus H2O. So combustion 1411 they give. Definitely it is minus because it is released. Fine. Now how do we balance this equation? Always it should be balanced in the order of CHO, combustion equations. So 2 carbons, write coefficient 2 here. Next 4, hence we write 2H2O. Last part is how to balance oxygen. 2 into 2, 4 plus 2, 6. Therefore here write 3 O2. So this is nothing but the combustion of ethylene, combustion reaction. Given information. Next, they are asking, they took certain amount, we don't know that, but if you take a standard value for oxygen, so we need to calculate that. How much mass you will get? Nothing but for oxygen it is 16, so 16 into 2 32, so 32 into 3 96 grams. If you take 96 grams of oxygen, no need to take ethylene here, we can take directly oxygen because the question is for oxygen. So how much you will have? That is nothing but 1411 kilojoules of energy. Fine. Next, you don't know the value of oxygen, how much they have taken. For that you got 622 kilojoules. So how to find out the mass of oxygen? From the mass we will calculate the volume. So for getting X, we take it as X is equal to 96 into 622 divided by 1411. So let us keep this as such. Now we got mass, and we know that 1 mole of oxygen has a mass of 16 into 2, 32 grams, and it will occupy 22.4 liters volume. This is a standard thing which you know. First we found the mass, then we need to calculate the volume. So to calculate volume, standard form, 32 grams of oxygen has occupied 22.4 liters. Now how much mass they have given? 96 into 622 by 1411 grams occupies, take it as X, cross multiply. Hope you have understood this. I have taken combustion equation. From that I calculated how much mass of oxygen is given, and standard value 32 will occupy 22.4. Now this much oxygen occupies X volume. Cross multiply, X is equal to 22.4 into this value, 96 into 622 by 1411. So this 32 divided by 32. So take your time and solve this. I already calculated this and I got 29.62 liters. So answer is B, 29.62 liters. Hope you have understood this. I will revise. First they have given combustion equation. You know the value here, that is 1411 kilojoules of energy is released out. And to balance combustion equation, follow the order of carbon, hydrogen and oxygen. Accordingly you got this equation, and we know that for this much volume, that is, first you calculate the mass, then we will get the volume they are occupying, like what will be the volume of O2 they are asking. So first calculate. So 3O2 has 96 grams, which will release 1411 kg, that is kilojoules of energy. Take it as X, cross multiply, and you will get mass of oxygen, and from the mass you can calculate the volume occupied by this using this equation. Hope you have understood this. Copy the solution, and in the next class we will continue with question number 6.